on to part 2 of lecture A. And you all have your reference tables. So we're going to be looking at reference table G. The one in your notes here is slightly different than the one in your reference table. So I'm going to switch to that one for right now, just so that it matches up the same. Everything I'm writing on the margin of table G, you can write either directly on your reference table or here in your notes. So table G looks like this. And the first thing we're going to do is label all of these compounds. So I'm going to write you a little cheat sheet list in case they use the names of the compounds instead of their symbols. And through the magic of video editing, in a second they will all miraculously appear. Ta-da! There are all the compound names. I'll read through them quickly in case you can't read my handwriting, and then after that it would be a good time to pause the video and write down all of the names somewhere in your own notes or on your reference table. So Ki is potassium iodide. That is a capital I on your graph, not a lowercase l. I would prefer they use the I with crossbars, but they don't. NaNO3 is sodium nitrate. KNO3 is potassium nitrate. HCl is hydrogen chloride. NH4Cl is ammonium chloride. KCl is potassium chloride. NaCl, sodium chloride. KClO3, potassium chlorate. NH3, ammonia. And SO2, sulfur dioxide. Notice ammonia is not the polyatomic ion ammonium. Ammonium polyatomic ion is NH4 plus 1. NH3 neutral compound is ammonia. Some basic graph reading skills that you should have. Solubility, make sure you read the units. This is grams of solute per 100 grams of water. This will be important in case they're not using 100 grams of water. For example, what do you do if they use 200 grams of water? Well, then you're just going to multiply your answer times 2. So make sure you're watching the units and watching the labels. So solute, this is the stuff that gets dissolved. And our solvent for all of these is water. So our solvent for all of these is water. Water right there is your solvent. Temperature down here. Solubility is related to temperature. Whether it's directly related to temperature or inversely related to temperature typically depends on the type of substance you have. In general, solids have a direct relationship between temperature and solubility. So that means their curves go up. So you can guess that Ki is a solid at room temperature, NaNO3 is a solid, KNO3 is a solid. And gases have an inverse relationship with temperature. When temperature increases, the solubility of a gas decreases. So you can guess that HCl with a negative slope and NH3 with a negative slope and SO2 with a negative slope are gases at room temperature. This is why really large fish have to live in cold waters, because more oxygen dissolves there. And if you let the temperature of your aquarium get too hot, your fish suffocate and die, because the warmer the temperature, the less oxygen can be dissolved. It's also the reason why your warm pop goes flat faster than if your pop is really cold. Okay, so those are just some quick things that we can read on the graph right away. The other thing that you should realize is when they talk about solubility, if they want to know which one has the greatest solubility, those are going to be the ones that are higher. So more soluble at a given temperature equals the highest line. So if they're asking you at, say, 20 degrees Celsius, which of 4 substances is most soluble, you would just follow this up, and the highest line out of the ones that they give you would be the most soluble. If they want to know where two compounds have the same solubility, that's going to be where the lines cross. So NaNO3 and KNO3 have the same solubility right here at approximately 70 degrees Celsius, maybe like 72. It's a little over. So same solubility where the lines cross. If they're asking you whether solubility increases or decreases, increases is a positive slope, decreases a negative slope. Most solubility, highest line, same solubility where the lines cross. Obviously, least solubility would be the lowest line. Solubility, this curve, is your saturated solution. This curve represents when your solution is saturated at that temperature. Okay, so the line is saturated. The line equals saturated. Line means where it is saturated. Back to our lecture notes. Example questions using Table G. They want to know what is the maximum number of grams of NH4Cl that can be dissolved in 100 grams of water at 70 degrees Celsius. Now, a lot of people get scared by this 100 grams of water thing and think they need to somehow match up 70 degrees and 100 grams on this graph, which won't because there's no line there. The 100 grams of water, remember, just mean you can use the graph directly. So if we go to 70 degrees and they want NH4Cl, here's NH4Cl. Make sure you're on the right line because the lines crisscross quite a bit. You're going to go from 70 degrees up until you hit this line, and then you're going to read across. They like you to be as accurate as you can, so I would use the edge of a piece of paper, and I read that as about 62 grams. Next question, how many grams of sodium nitrate can be dissolved in 50 grams of water at 30 degrees Celsius? And here's where you have to be careful. They've said 50 grams of water and not 100. 50 grams of water and not 100. So we're going to look at what the graph says for this problem. And our graph says at 30 degrees Celsius, now sodium nitrate, notice they made it harder by giving you the name instead of the formula. Sodium nitrate is NaNO3. 30 degrees Celsius, all the way up to the line for NaNO3. It's this line right here. We're at, say, like 96. So you can do this as a proportion or just kind of think about it in your head. If 96 grams would work in 100 grams of water, then how many grams in 50 grams of water? Well, it will be half of that, so we just take 96 and divide it by 2, and so our answer is going to be 48. Most of that are graph reading skills. We're going to practice that in class. We have worksheets practicing reading this graph and doing the change over if they're not using 100 grams of water. So make sure you're paying attention when we go over that in class. We can also use this graph to decide whether a solution is saturated, unsaturated, or supersaturated. Now remember, the graph itself is giving you saturated solutions. The graph itself is saturated. That's where the line is. But if they give me volumes and temperatures and I match those up on the graph and I check to see where those fall. So if they say they have 110 grams of NaNO3 dissolved at 20 degrees Celsius, 110 grams NaNO3, 20 degrees Celsius is right here. That's way more than should dissolve. For NaNO3 at 20 degrees Celsius, a saturated solution is about 88 grams. If I have forced 12 more grams to dissolve in there, then I would have a supersaturated solution. So any amount and temperature that match up above the line, it has more dissolved in it than it should, it's going to be a supersaturated solution. If they match up exactly on the line, if it says it's 88 at 20 degrees Celsius, then I have a saturated solution. And if I only added 80 grams at 20 degrees Celsius and I'm below the line, it's going to be unsaturated solution. So remember that the line itself is saturated. So if you're on the line, it's saturated. If you match up and you're above the line, you're supersaturated. And if they match up and you're below the line, it is unsaturated. Now, some of the things they'll ask you, if they put in 80 for NaNO3, for this line right here, and you know it's unsaturated, they'll ask you how many more grams can you add? Well, you can add 8 more to make it saturated. If you're up here at 110 and it's supersaturated, and they say they add an extra crystal, how much will precipitate out? Well, you'll lose the 5, 10, 12. You'll lose the 12 grams extra that shouldn't be in there. That's how much precipitate you'll make. So it's just basic graph reading skills, and you just have to remember where on this graph it's going to be saturated, unsaturated, and supersaturated. And then, of course, just general solubility things. In general, there's a direct relationship. Solubility increases with temperature. That is, of course, going to be for solids. Gases show the opposite. So in gases, when we increase the temperature, we decrease the solubility. We already saw that on the graph. Those are going to be things with negative slopes. And the last thing you have to remember here is pressure. Pressure only affects the solubility of a gas. So if we increase the pressure, we increase the solubility of a gas. Think of a bottle of pop. As soon as you decrease the pressure, when you unscrew the cap, the carbon dioxide starts to come out of solution. It doesn't stay dissolved. When you put the cap back on, the pressure can build back up in there, and then the solubility of your gas increases. So we increase the pressure, we increase the solubility of a gas. There is no effect of pressure on a solid or a liquid. None. So I've seen test questions where they ask you to graph the solubility of a compound, and it's a solid, and you graph it, and the line goes up, and they say, what happens when you increase the pressure? And the answer is nothing. If you have a solid or a liquid, when you increase the pressure, nothing happens. Nothing is going to change. If you have a gas and you increase the pressure, then the solubility increases. So it only affects the solubility of a gas. All right, we'll practice lots of Table G in class.